Okay, this is a very logical theorem, I think. It follows immediately from triangle sum theorem, and we don't need to do much work. It just says that if we have any two angles in a triangle, sum to the exterior of the third, right? So that's a complicated way of stating this exterior angles theorem, but it's useful to think of it that way. Okay, so what's the exterior angles, right? Like the exterior angle to A is this angle right here. The exterior angle to C is this angle right here. And if you want, you could even look at it as this angle right here, right? These are both exterior angles to C because they're equal due to vertical angles theorem if I continue these lines. So what's the exterior angle to B? It's this angle D right here, right? And I'm going to show that for any combination, it doesn't matter. This is random what I'm showing here. I wrote it wrong, so we got to fix this. So it's what do I want to say? A plus C, or A plus B is equal to D over here if you want, but let's make it A plus C, or let's do this right. Let's make it clear. What should I do? I'll do A plus C, whatever. Okay. A plus C, this plus this, is equal to the exterior of the third. This angle, any two angles, A plus C, is equal to the exterior of the third. Okay, so how do we do this? Well, we could say measure of A, right away, measure of A plus measure of B plus measure of C is equal to 180 degrees. This is by triangle sum theorem. Okay, the sum of the interior angles is 180 degrees by triangle sum theorem. Then you could say that B plus D clearly form a line. So you could just say, in this case I haven't named this line, but whatever, you can give it a name if you want. If you just say form line AB or form line AD, it's sort of clear. But okay, but B, measure of B plus measure of D is also equal to 180 degrees. Okay, since they form a line. I don't know, or ray, whatever, form a ray, line L. Since they form line L, whatever, okay? Then, now I have that this is equal to 180, and this is equal to 180. So by substitution, the measure of B plus the measure of D is equal to the measure of A plus the measure of B plus the measure of C. And then you have the measure of B on both sides of this. Oh, wait, why is that true? By substitution. By substitution. And then I have the measure of B on both sides, and I subtract it on both sides, getting that the measure of D is equal to the measure of A plus the measure of C, which is what I wanted to show. So by subtraction, your final step, by subtraction. Because I subtracted, what did I subtract on both sides? I subtracted the measure of B on both sides. And it's nice to show that. Because the measure of B minus the measure of B is 0. 0. And then I'm left with that the measure of angle D is equal to the sum of the other two angles in the triangle. The exterior angle of the third. This is the third angle. The exterior is D. It's equal to the sum of the other two angles is what this theorem is stating in any triangle. And you're done in this. Okay, because again, you ended with what you wanted to show. I just wrote it the other way around, which is obviously the same thing. Okay.